Hello, everyone. Thank you for being here. Good morning if you're in the Americas. Good evening if you're in Europe or Africa. And I guess everyone else, you're staying up way too late. But we're glad you're here. So thank you for being here. This webinar is called Using Security Tools in Smart Contract Development. And today we're going to show you how you as a smart contract developer can easily add security to your workflow. Now we know it's tempting to want to put security at the bottom of your to-do list because you might think you'll just get an audit at the end of your project, but that could be an expensive decision, and you don't need to be an auditor to benefit from the security analysis tools that exist today. And these are tools that anyone can use. And in this webinar, we're going to show you how. So first off, before we get started, let's do some quick introductions. So I am Mike Pumphrey. I'm the marketing and brand manager for MythX. So I act as a translator. I like to say that I translate blockchain into human, and I'm going to be the moderator here. For the presentation, we are privileged to have Bernhard Mueller, who we call the Chief Hacking Officer of MythX. Bernhard has years of experience in the smart contract security space and was the original author of Mithril, which is an open source security tool. And these days he leads the team at MythX. So he's going to be giving the presentation today. We also have Dominic Muse, who is going to be kind of acting as a kind of batting cleanup. So he is our one of our lead developers and knows everything about everything. So he is going to be answering questions and fielding content and just helping us out. So thank you very much. And so before I hand the mic over to Bernhard, I would just want to mention a few ground rules. First of all, this webinar is being recorded and it's going to be broadcast and sent out at a later date. Also, I'm going to send this out to people who can't make it because this time doesn't always work for people. No worries. Second of all, we want this to be a two-way communication street here. So we all encourage questions throughout the presentation. No need to wait for a pause before typing a question in. Please use, if you would not mind, the Q&A section of your interface to input questions. In your bar, you see a Q&A button, and that will, you can test that out here if you want. And that just makes it easier for us to figure out where the questions go. The chat, feel free to use the chat and hang out and chat with everyone. But you know, the chat can get a little messy. So please put stuff in the question and answer. Also, just to make sure that everyone's engaged, want to start just quickly with a quick poll. And so I'm going to set this up. So what we're interested to know to start out here is, what development environment do you use or are you currently using? So I think you can only do a single response with this. So if you use more than one, just select the one you use the most. I'm going to click launch polling and give people about 30 seconds to a minute or so. Wait and see. So I'm going to share the results here. You can see what your peers and your colleagues are doing. So you can see it's a kind of a two-way tie, give or take, between Truffle and Visual Studio Code, VS Code. So that's interesting, but there are a lot of Remix folks out there as well. And curious about that other. Sorry we couldn't have a text field in there. So if you want to specify the dev environment that you're really into, feel free to put that in the chat. We're curious. Okay. I'm going to stop sharing the results. And with that, I think we're all set to go. I'm going to pass the mic over to Bernhard and stop sharing my screen. And you can take it away.
All right. So I was forced to do some PowerPoint slides for this, and I made only 3. So now I'm going to try to share my screen and not mess this up. So in this talk, I'm going to talk about, in this webinar, I'm going to talk about 2 things mainly. The first one is detecting generic bugs in smart contracts, and the second one is checking for custom properties. So that's probably the more interesting one. In this part, we will learn how to leverage the fuzzer and SMT solver that's built into MythX to check assertions. and find counterexamples to assertions and expressions or properties that we expect to hold. And we look at different types of doing that, including invariants and checks on functions that have pre and post conditions. A brief overview about MythX. MythX is an API service that applies multiple types of analysis to the solidity code and EVM bytecode you submit. So basically, you submit all the compiler artifacts that you have, which means that your project has to compile successfully. And then this goes to a number of tools in parallel that run for a certain time, which includes gray box fuzzing and symbolic execution. Fuzzing basically means that we test the code with random inputs. Not totally random, but it's quite intelligence in how we try to achieve the biggest possible coverage in the time available. And the second approach is SMT solving and symbolic execution. And in that method, we represent the program as a set of logical equations and use the SMT solver to determine if certain states are reachable or not, and if there are, what inputs we need to supply to reach those states. And yeah, it will be much easier to show that by example. Just a brief overview of the options to use MythX. So MythX itself, the base service, is an API, but we have front ends for various IDEs and command line tools with integration with Truffle, Remix, Visual Studio Code. We have a standalone command line interface that's written in Python by Dominic, which allows you also to use Remix MythX in the CI pipeline by using these command line tools. We've recently also added some special flags to Truffle so that you can, for instance, block a deployment if critical vulnerabilities are discovered and some nice things like that. And to use MythX, you can sign up for a free account on our website that gives you the credentials and the API keys to use it. And all the examples I'm going to show in this webinar are in this GitHub repo. If you want to try them yourself, you can do so right away. And that concludes the presentation. So now I'm going to share, I'm going to use Remix during this webinar because it's just the most straightforward way to do stuff at the moment and has a very nice user experience, except for some small minor bugs that are soon going to be fixed. So let's start with a very simple example. And a pretty good way to show how MythX works is by using it on war games, like the ones from Ethernet and Capture the Ether, because those are pretty basic examples for common bugs or basic bugs. And so we're talking now about generic detection. There's a number of detectors built into MythX that look for very specific conditions that we think are usually, in the most cases, bad. And one of these conditions is if an arbitrary attacker or an arbitrary sender can withdraw any amount of Ether from the contract, or at least specifically the rule is that if you can withdraw more Ether from the contract than you ever sent to the contract, then we flag this as a possible vulnerability. So to get started with MythX, you have to activate the plugin, which I already did. It's found somewhere here in the plugin list, and set it up with your credentials. So you head to settings, enter your address and your password that you set up on the website, and then you're good to go. So that's the free account. And all the examples here work with the free account. So there are basically not a lot of limitations on that, except for the compute time that you get the tools to run. And these examples are simple enough that you can solve them with the 2 minutes that you get in the free account. To run the basic analysis, you compile the contract, make sure that it compiles correctly. And then we'll hit the analyze button. And the quick analysis usually takes about a couple of minutes, but for me it now works faster because I just ran the examples before to try them out, and the results are already in the cache. And you get the results here in the report tab. You can click on the result, which will highlight the code that MythX thinks is affected, which is in this case the transfer of Ether to the message sender. And you can get more details by clicking on this little arrow here that will give you the description. And most importantly, it will give you the transactions that were sent to trigger this issue. Right? So, and if you look here, so basically the thing in this challenge is you have a private variable that contains a secret value. But as we know, nothing is really private on the blockchain. So this is obviously not a secure thing to do. So MythX can figure out that if you call the function guess with this particular input, then this will happen. And this is important for you to be able to reproduce what's actually happening, which is in this case pretty trivial, but can of course be much less trivial. So example number 2, most of you might have heard of the parity wallet library, which was accidentally killed, freezing a lot of Ether in the contract forever. And this was because of a mix of things. There was an initialization function and a state variable that was supposed to be initialized but wasn't. And essentially you could make yourself the owner of the contract and then call the self-destruct functions and also send the Ether to an arbitrary self address, which is probably yourself in that case. And if I analyze this now, this should detect the issue as well, along with some other stuff. But this stands out obviously. So anybody can kill the contract. But if you see this here highlighted, it's not immediately obvious why this is the case, because this is an only owner protected function and it has the modifier, and the modifier checks whether you're the owner or not. So again, it's important here to look at the produced transaction trace. And now you can see that there are 2 transactions that are necessary to trigger this issue. And here we have a little bit of a GUI problem because you cannot, if now theoretically I can pull this thing over, but then it will mess everything up. So I just copy this out to look at the transactions. The first call is to init wallet with an empty list and some pretty random large number and the value 0. And if you look at the function itself, that means we have an empty owners array, then required is something random, doesn't matter, and daily limit is 0. So this initializes the wallet, and if you look at this function, this will make the message sender the owner. And you also have in this transaction trace the sender of each transaction. And we have some standard addresses that represent different actors. The 0x Affe. Affe is the German word for monkey, which doesn't really matter. But for Austrians, it's kind of fun. That's always the creator, and we also assume that it's the contract owner. And that beef is always the attacker. So you can see that the creator creates the contract, and then an attacker initializes the wallet, sets themselves as the owner, and then it kills the contract, and it also sends the Ether to themselves by passing its own address as the first argument, right? Because it's also something. So in MythX, we try to do that, and if it cannot do that, it will just not extract the Ether and still kill the contract, which is also a critical bug. Yeah, so I guess the main takeaway from this second example is that you can have bugs that are a little bit more complex and require a sequence, a very specific sequence of transactions to be executed. And this is where the difference between the analysis modes comes in, because theoretically, if you have issues that require the state to be modified or mutated over several transactions, then this can be an infinite number of transactions, and it's not possible for the tools to go infinitely deep. So the analysis time you have available effectively limits the number of transactions you can go. But it's sufficient in quick mode to discover this, for example. So are there any questions coming in the meantime, or we should address?
There are a few questions coming in, but looks like Dominic is on point with those. Just a reminder for everyone, if you have questions for Bernhard, throw that in the Q&A so we can see it. And yeah, no, I think you're good to go with another example.
So now there's a little bit more interesting example, which is from Capture the Ether. And by the way, if you want to play these challenges, just head to capturetheether.com and open Zeppelin Ethernaut, and you will find this code, and you can try this out yourself. So here we have a token sale, and I'm not gonna look at this in detail, just gonna run it through MythX now and see what it says. And now we have detected a binary multiplication overflow here. So apparently there's no check on whether this multiplication overflows, right? That means that theoretically, if I mint or buy tokens, I can buy a large amount of tokens and overflow the value in a way so that I have to pay nothing. And nothing would mean that message value is 0, right? So if I look now here at the details, I get an example from MythX, and looks like this. And that's a very large integer that will obviously overflow the variable. So I just realized that I'm not sharing my whole screen, which causes you not to see my text editor. So we change that quickly. So what I wanted to show is, this is the counterexample provided by MythX. But if you would actually like to exploit this, what you really want is to get tokens but send 0 ether, right? So a nice way to cheat on this challenge now is to add an assertion. So what we want is to have a transaction where message value is 0, but num tokens is greater than 0, right? So, and we can write it in a way that it should always be the case that either num tokens is 0, or if not, message value has to be greater than 0. So stated in a positive way. And if you assert this, then MythX will automatically check that this is either always the case or find a counterexample to it. So just rerun this now. Okay, so now we have an exception detected, which is here. And this is now exactly the case where I send no ether, but get more than 0 tokens for that. And this is a very specific value that I have to send. With this one, I will just copy this out again. So this is the value, right? And we can assume that if we multiply this with 1337 ether, that the outcome will be exactly 0. All right. And I can also try this out by just deploying the contract and giving it exactly the value that was output from MythX. Okay, but I'm not going to do that now. You can do it yourself if you want. I tried it out before and it works. So that's a good way of cheating on CTFs. And also a first demonstration of how to use assertions with MythX. So let's go back, step back a bit to the basics about assertions. So like I said, an assertion is something that you claim to always be true. And so let's say you write a normal unit test, right? In a unit test, you test some function and you give it a concrete input value, and then you expect a certain output. But if you do the same with MythX, it will check the validity of this statement for all possible input values. So it will take all values of X and check whether this is always true. And besides the vanilla solidity asserts, we also support another type of assertion, which is the assertion failed event. The advantage of this is that you can add an arbitrary string that will then also be included in the report output. So it makes it a little bit easier for you to reconstruct what actually happened. I will show you that really quickly. Okay, so here's a little IDE problem that we're currently fixing, that the access token sometimes times out, so you have to relog in. So if you reach this assertion here, you can see here in the description that you will have your message. And also here the value that needs to be in X, which is the result of this multiplication, because the solver can easily solve this, right? It can just say, okay, if this multiplication, the result of this multiplication matches X, then X needs to be that, and then this assertion will fail, all right? And that's the basis of all the custom checks we're going to write in the next examples.
Bernhard, we're starting to get a few questions in here. So I wanted to start just real quick with one that Dominic already fielded, but I wanted to put this to you as well, just because I wanted to get your take on it. Juan Lopez asked, do you use some kind of CVE? And so figured you could talk about that.
You mean in terms of classifying vulnerabilities?
Yes.
Yes, we do. So if we just go back to the last report, I will just show that with the next example. This is another challenge from Open Zeppelin. It's level 17, I think. And this is a registrar contract. And the contract is supposed to be locked so that nobody can make any more entries. And this is controlled by a Boolean variable, right? So it's not unlocked. Unlocked is false. And there is supposed to be a way to make unlocked not false. But if you look at this code, then there's actually no direct way of setting this variable. So I don't know, maybe some of you already know the solution or have some ideas, but you can always make your life easier by using MythX. And the generic way of cheating on CTFs with MythX is just asserting that the solution doesn't happen. Like you do something like function invariant as you can see, I suck at typing. And then you just say assert. It's not unlocked. This should never be unlocked, right? So now I just throw this at MythX. And this might now actually take a couple of minutes, so I quickly answer the CVE question. So what we have created, and actually this is a community-wide project where we have also got contributions from chain security, trade of bits, and a lot of others, where we categorize different types of generic bugs into classes. At the moment we have 33, I think. And any result you get from MythX will map to one of those classes. Okay, so it looks like this has not worked. Interesting. Did I do something wrong? Just to go back to this quickly. So here's the link to the SWC, Smart Contract Weakness Specification entry. And if I click on that, it will show me the exact description of this particular issue or best practice record violation, along with some examples. And another thing we provide is configuration files that specify exactly where the issue is in the source code or in the bytecode, if applicable. So you can also use this to benchmark tools. And it's also what we use to benchmark our own tools. So we just try to get positive results and no false negatives on any of these examples. And so anything that's added here, and you can contribute on GitHub, obviously, will also improve the quality of our security analysis because it will incorporate it. So I wonder why this did not work. Okay, I just skip over this, and hopefully I'll be publishing a blog post in the next days that also contains this example, and until then I will figure out why it didn't work right now, and yeah, update you on that. Just skip over this. So this is a very interesting one that's from an actual project that we did for 0x a couple of months ago. And this is an example for writing functional checks, where you want to ensure that a specific function works correctly under all circumstances. And the particular challenge here was to verify a library that implemented operations on signed fixed point integer variables. And the point of this library was to ensure to have functions that prevent overflows and underflows. This is one of the functions from before the functions were fixed. This is supposed to add two signed integers and revert if there is an overflow and underflow. So what you can do now, and what we usually do, is to create a contract that is derived from the contract being tested. So we inherit all the functions. And this is the effect that we don't have to touch the original code, right? We can just put this into a separate file, maybe create a test file and run this, and we don't have to annotate or change anything here. And then we wrap the tested functions into tests. And in this case, we want to ensure two things, which are pretty straightforward. So if you add two positive numbers or 0 and a positive number, then the result must always be a positive number. And if you add two negative numbers, then the result is supposed to be a negative number, right? So this makes sense. And we have two things here in these functions. The first are preconditions, and those tell us some constraints on the variables. So we want both A and B to be positive, or we want A to be at least 0 and positive and B positive. And the second function is the preconditions are that A is below 0 and B is lower than 0. And then we add them. And then we have a post condition that says, now the result is supposed to be greater than 0, and here it's supposed to be less than 0. And so this is pretty good and useful during an audit as well, because this kind of code is not super intuitive to understand, right? So you might not immediately know if it's correct or not without thinking really hard about it. So you can basically also cheat here by just letting MythX figure it out. Okay, let's see.
While that's going, Bernhard, there's another question that's coming in. This question is from, I'm going to say the name wrong, I apologize, so I'm not going to do it. Is it reasonable not to check variables for overflow at times? For example, each transaction adds 1 to a uint 256 variable. Realistically, the limit wouldn't really be reached. Can you speak to that?
Sorry, again, if you add a uint 256 to a uint 8 or something.
Yeah. Question is it reasonable are there situations where you don't need to check a variable for an overflow?
Yes. It's a good question. So I'm not 100% sure what happens if you add 2 uint 8s, for instance, but I think it really depends how the compiler translates this addition or multiplication, right? And if it accounts for the possibility of overflow or not. I think it's always better to change for overflow and underflow, no matter what types of variables you use. So obviously,
to chime in here real quick, I think the question was also aimed at business logic related constraints. So basically, you have a uint 256 or some really large uint, and every transaction that goes to the smart contract is basically increasing that uint by 1. So MythX would detect an overflow, of course, but it might be unfeasible in practice to actually exploit that vulnerability because it would take way too much time or funds to pull that off. So in that case, if MythX, or when MythX detects that, you have the chance with the official tools to blacklist that SWC ID for an integer overflow, underflow inside the tool. So you can selectively ignore the stuff that you deem unfeasible. And that's also going to work out in CI, for example.
Right. So for instance, if you track ether balances, then I think it's impossible to overflow that variable because the total amount of array available in the Ethereum blockchain is less than the maximum possible 256-bit integer, right? I mean, I would be surprised if it would be more. I made a small mistake before, so it's important here if you have 2 contracts in the file to pick the right one for analysis. So here we have the exception. So there's exactly one case of underflow here. And this underflow happens, and I will copy out the call data here again. It looks like this. If you add the smallest possible negative integer and the same smallest possible negative integer again, then the result will underflow and the result will be 0. And we can just try that out. So you can always just copy paste this stuff here and run it. So you see that this is actually true. So you get 0 back. And this was fixed by 0x. back in October or November when we tested it, so that's not an issue anymore. There were a number of other ones in multiplication and division, but I think you can see how this is useful, having this kind of check, right? Because you might not really think about that intuitively. All right, so I have one more example here. I'm not sure if you have enough time for that. Is there a lot of questions that popped up? Or...
No, I think we got time. We got time for one more example or so.
Okay, so this is probably the most complicated one. That so this was posted quite a while ago by Open Zeppelin, and it's a variant of the MakerDAO bug. So MakerDAO has a critical bug that was discovered by Open Zeppelin. This is a voting contract where people deposit tokens, I think, and they vote on proposals with the weight of the tokens. And it turned out that there was a bug, a pretty subtle bug, that allowed people to basically erase voting weight from other users by calling a sequence of transactions. And it's a little bit complicated to explain. What essentially happens is that if you vote for a proposal, proposals map to addresses. If you vote for an address for the first time, then there's a process called etching that hashes the address and creates a so-called slate. And this slate then maps back to the address. And what an attacker could do was to directly vote for a slate that was not yet mapped to an address. And if later a user voted for the actual address, the attacker could make another vote and effectively, how to put it, roll back the voting weight of the other user. And this is quite a complicated bug because it involves hashes and nested hashes and nested arrays, and it's pretty difficult to analyze, but we can handle that now as well. But in this case, you actually need to run the full mode analysis because this is quite a complex contract, and there's a few difficult tasks that MythX has to solve, and you just cannot do it in the 2 minutes runtime. And if you run the full analysis, you get a full 30 minutes of fuzzing and symbolic execution, and that's plenty enough for solving this challenge. So what happens if I start full mode from Remix is that it's asynchronous, so you will not get the result in Remix, but it will link you to a report dashboard, and then you can track the progress of your analysis. And since we don't want to wait for half an hour now, I will just show you a past one that I did before, if I can find it. Apparently I can't. All right, so in the report dashboard, you see all the historic analyses that we ran before. And this is the assert violation that was detected. And this is basically a special case of the vulnerability. So if you vote for a slate with a particular bytes 32, and this 32 bytes is the hash of the address that's later etched, then your voting weight will not anymore will not be counted. Basically, it will be erased. So, yeah, that was a quick intro to a report dashboard as well. yeah. So that's pretty handy if you kind of, especially if you use things like Truffle, the Truffle plugin, which doesn't give you as verbose information as Remix. It's much more useful to just go to dashboard and look at the report there. Yeah. And that concludes the examples I wanted to show you.
All right, we got a few more questions here happening. This one's more of kind of a high level one from Bipul Dabi. It was asking, does MythX work with permissioned blockchains like Hyperledger?
It does work with the variant of Hyperledger that is based on EVM, which I think is Hyperledger Fabric, as far as I know, because Hyperledger is like incorporates a lot of technologies, and we support at the moment only Solidity and EVM bytecode. It does work with any blockchain that uses this kind of technology, like VeChain, Quorum, Tron, even though Tron is obviously a scam, but doesn't matter, it still works with Tron as well. So yeah, everything that's EVM based.
Great. And another question that just came in, could we consider MythX as an alternative or for JavaScript tests? I think that's what that meant.
I would say it's an augmentation. So like I said before, if you have JavaScript tests or unit tests, you check specific concrete cases, right? You have a certain negative or positive outcome that you want for a certain value, and then you test that this behaves as expected. But what you cannot do is check things for all possible input values or all possible states. And that's where input fuzzing and SMT solving becomes useful, because you can find exceptional cases that are maybe counterintuitive and you didn't expect, and you were not even thinking of when you were designing your tests, because nobody can think of everything, right?
And I think earlier in the chat, I think I saw someone who asked a question about SMT, and if you could say more about what that is.
So SMT is short for satisfiability modulo theory, and basically it's a way just of solving propositions or solving formulas, right? So for instance, if I go back to one of the examples, let's say here we have an overflow, and we want to know, we want to have an assertion where we say assert message value 0 and is 0. So the symbolic execution engine, if it gets to this point in the program, it will see that assertion, and it will just create a huge logical proposition, or basically a formula that incorporates all the input variables and all the steps to get to that point. And then it will try to solve this formula. And the variables in this formula are the input values. So it will calculate the value for num tokens that num tokens has to have that this evaluates to true, right? It's basically an automated solving tool. Does it answer the question, or was it too abstract?
Well, if you still have questions, you can put that in the chat. If anyone has any other questions, just now is the time to start typing those things in, and we'll get to those.
Actually, for this, I've given a couple of talks on Hack in the Box and DEF CON about this exact topic, where I explain it like for an hour or so exactly how SMT solving works. And there's also some blog posts about it. So another tip, going to my GitHub in this case. There's a repository called Awesome MythX Smart Contract Security Tools. And if you scroll down here, there's a list of articles that explains how most of this stuff works. And for example, there's a very nice article by my colleague Björn that goes through the basics for symbolic execution and shows exactly how these results are obtained and how the solving works and how we build the space state of the program and the control flow graph. So if you're interested in this, you can dive into these articles. But fortunately for MythX, just for using MythX, you don't really have to know how it works. You just have to accept it.
Great. We have another question that just came in. For a normal day-to-day work as a smart contract developer, can I solely rely on the MythX tool, or do you recommend other tooling that other smart contract developers should look into?
Well, I think for tooling, MythX has pretty much all you need. You should still do a manual audit as well. So it will not, tools can never cover everything with 100% accuracy, right? There can always be things that you overlook. So you should have an experienced security guy look over your code and understand it and understand your business logic, and possibly also help you write those tests and assertions that I mentioned, because that requires a lot of expertise, right? You cannot just throw your code at MythX and expect it to give you great results if you don't have good security properties and good assertions. But I think in terms of tools, it integrates pretty much everything that you can also find like in terms of open source tools. Like, I mean, you can build your own tool stack with fuzzes and symbolic analyzers and things, but it's probably more convenient to get all of this in a single API, which is kind of our UVP, unique value proposition.
Very nice.
And it doesn't only do the fuzzing and symbolic analysis stuff. We also have a static solidity analyzer that we are now has EIR support, and it can do pretty much everything what, for example, Slither does. So you get all this low-hanging fruit type stuff as well.
Great. The next question that we have here is, are there inherent security flaws with old compilers? Can an old compiler become insecure by default?
Yes. So we would definitely always recommend to use one of the newer compilers. We also don't support anything below SOC 0419, I think. 049 or 19, because it's just, it doesn't make sense to use an old compiler. If you write new code, why would you intentionally use an old version of SOC and risk having compiler bugs? So I think yes.
And I'll just add that that using a floating pragma, the floating compiler version, actually is one of the SWC issues that will trigger a warning in MythX. You want to link your code to a very specific compiler version. So
that's an SWC because we generally want you to be as specific about your code as possible, right? We want to know exactly what compiler is used, because if you check with a different compiler version that is then actually used to compile the contract that goes in the mainnet, then we might miss bugs that were introduced by that other compiler version. So if you write a smart contract, you should be very, very sure about what compiler version you use and how it compiles and how it behaves and what the components are and what your security properties are. It's not like you write a web application and then if something breaks at some point, you just patch it, because you just cannot do that with a smart contract, except if it's upgradable. But that's a whole other story. So, in my opinion, there should not be upgradable contracts, which is now maybe controversial, but it kind of defeats the purpose of the whole thing, right?
All right, thank you. Okay, we just have a few more minutes for questions. Probably only take one or two more. Next one is self-styled noob question, which is totally okay. When a critical bug is found in a contract, such as the MakerDAO reference, how is the bug patched without causing issues to the current blockchain, because the whole purpose is immutability?
Right, it's not easy. So I think in a specific case, a new contract was deployed and users needed to migrate their tokens to the new contract manually. So there's no other way to do that. Unless you have a delegate call proxy where you can just have one guy who can switch out the code. But this is exactly what defeats the purpose. You need at least to have social consensus that all users want to move to a new contract, and then you deploy a new contract, and then you incentivize users or tell users to move over their token balances to that new contract. And that's how it was done in the MakerDAO case.
Great. And so another one just came in. We don't really have time for this, but can you show how to use MythX in CI, continuous integration?
Yes, actually we have a blog series on exactly that coming up by Dominic. So the one way is to use the command line client. The other way is to use Truffle security. And so if you install our Truffle plugin, you will get a Truffle run with X command. And what this does is it analyzes all the contracts in your Truffle repo. And then it has some flags that makes it a little bit easier to use it in CI as well. MythX. So for instance, you can get a non-zero exit code if there are certain types of bugs. You can, for example, say, if there's a critical vulnerability, then block the deployment. Or you cannot do that. You can just output the report somewhere or see it on the dashboard. But I think this should be pretty easy to run in a CI pipeline. It's just Truffle run verify and does everything by itself. And yeah, MythX CLI, our command line tool, it allows you to do similar things. And yeah, like I said, we'll have a detailed how-to on that very soon.
Very good. Any final words, Bernhard, before we close this up? We're just about at time.
Final words. Well, I don't know. If there are any questions, just hit me up on Telegram or Twitter or whatever. So I'm always glad to help. Okay. And please sign up for MythX accounts and try it out. And I think we already announced that we are going to have new subscription plans. So there will be a cheaper plan for individual developers, which is $50 a month, I think. And then you get the longer analysis modes where you can go deeper with the analysis and get a lot more confidence that your assertions hold and that there are no bugs in your contracts. And also a more expensive plan. And right now we only have an expensive plan, which kind of sucks a little bit for normal people.
Yeah, so yeah, take a look upcoming, we're going to have some new announcements about new plans and new features and new abilities, ways to pay. So just to keep on our radar and make sure you're checking out the MythX blog and sign up for our newsletter. We're just about at time, so I'm going to wrap this up. So thank you, Bernhard, for the presentation, all those examples, and for answering all those questions. Hope people learned a thing or two. We'll be sending out some information after the webinar, so be sure to look for that. And also thank you, Dominic, for answering all the questions in the chat and managing that. That was great to have you on there. Hope everyone got their questions answered, but if not, again, we are available. You can follow us on Twitter. So the MythX Twitter is MythX_platform, or you can just Google it. Bernhard's Twitter handle is well, you can just Google Bernhard Mueller and you'll get his handle, and we can always send that out as well. Sign up for MythX and give it a try. We've got a free plan for everyone, and you can you can add security into your workflow for free right now. And that's something that we all should be doing as smart contract developers. As always, I want to thank everyone for your attention and time. We all really appreciate it. And just remember, it's up to all of us to help keep Ethereum secure. And take care and have a great rest of your day.